V speeds are determined for each weight, flap setting, pressure, altitude, and temperature. V2 and VR are first determined with an engine out. Then the initial climb, pitch, attitude, and airspeed are determined for the all engines case. V1 is determined after V2 and VR. V2 is determined first. With an engine out, an initial climb is established at a minimum V2, which is 18% above stall speed and 10% above VMC for the specific takeoff condition. The climb gradient is then measured by a simple formula to determine whether the 2.4% climb gradient requirement is met. If not, the climb is repeated at a faster speed until the climb gradient is at least 2.4%. Remember that increasing the climb speed toward the best angle of climb airspeed will improve the climb gradient, since the best angle of climb airspeed is typically considerably faster than the minimum value of V2. This simulation shows an engine-out climb for a wide-body jet transport with a gross weight of 320,000 pounds. Flaps 5 is a normal takeoff flap setting and is a compromise between minimum ground run and a maximum climb angle. The minimum possible value of V2 is at least 18% above stalling speed and 10% above VMC. For these simulated conditions, the minimum V2 is 154 knots, which easily exceeds the 2.4% climb gradient by climbing at better than 1.4 degrees. The pitch attitude for this climb is noted since rotation to this attitude will occur at VR. With V2 and its associated pitch attitude determined, VR will be found experimentally. At various airspeeds slightly before V2, rotation at 3 degrees per second to the V2 pitch attitude is accomplished. The rotation speed that establishes and holds V2 without overshoot or undershoot becomes VR. The first simulation is a rotation at V2, which overshoots the V2 of 154 knots and results in an excessively long ground run. The second simulation is a premature rotation in which the required V2 of 154 knots is not reached until well over 300 feet. The third simulation begins at a rotation speed of 150 knots, 4 knots before V2. In this case, the V2 of 154 knots is reached prior to 35 feet and maintained to 400 feet. So VR in this case is 150 knots. We have now determined V2 and VR with an engine out. The same VR and 3 degrees per second rotation rate are also used for the all engines case. However, the initial climb airspeed and pitch attitude will both be greater. This is an advantage since the greater climb airspeed is closer to the best angle of climb speed. The all engines initial climb airspeed and pitch attitude are determined by rotating at VR and 3 degrees per second, with all engines operating, to a trial pitch attitude and observing the airspeed trend. When the trial attitude produces a constant airspeed climb, both the all engines climb pitch attitude and airspeed have been determined. In this demonstration, VR is 150 knots, and rotation occurs at 3 degrees per second to several trial pitch attitudes. In this first case, the initial climb pitch attitude is too low, and airspeed increases in the climb. In this case, the initial climb pitch attitude is too high, and airspeed decreases in the climb. Finally, in this case, the climb pitch attitude maintains the airspeed at a constant 161 knots. In summary, both the all engines initial climb pitch attitude and airspeed are found at the same time. In this example, they are 15.4 degrees and 161 knots. FAR Part 25 requires the same VR must be used for both engine out and all engines takeoff performance requirements. Since the climb pitch attitude must be higher for the all engines case, the initial climb airspeed will be greater than V2, because rotating to a higher pitch attitude takes longer, while the acceleration with all engines is greater. Therefore, the all engines initial climb speed is always equal to V2 plus an additional speed increment. In this case, the correct initial climb speed of 161 knots is equal to V2 plus 7 knots. It is worthwhile to remember that both engine out and all engines initial climb speeds are significantly less than their respective best angle and best rate values.